Anyone who knows about nuclear weapons knows this was the biggest bomb ever built. The Tsar Bomba. The Tsar Bomba was about 7 feet wide and 26 feet long. Its total weight was roughly 53,000 pounds. The bomb's outer shell was made of steel with a beryllium lining. Inside, it was wrapped in a layer of synthetic fiber insulation. The insulation kept the explosives and nuclear material at a stable temperature. In the front of the bomb's nose cone sat a radio altimeter. There was also a barometric pressure sensor. The tail of the bomb had 3 fixed fins to keep it aerodynamically stable as it fell. At the very back was a multi-stage parachute pack. It was used to slow the bomb down as it dropped. To drop the bomb, they used a Tu-95 strategic bomber. The belly of the bomber was modified specifically to carry the bomb. The test site for the Tsar Bomba was chosen on Novaya Zemlya in the Arctic. Take a close look at this terrain. Doesn't it look familiar? It kind of resembles a certain troublesome neighbor that's been acting up again lately. After the bomber passed over Novaya Zemlya, the pilot pressed the release button. The bomb began its free fall. To slow it down, the parachute system deployed immediately after release. The parachutes at the tail opened one after another. The parachutes were used so the pilot would have enough time to fly the plane to safety. He needed to reach a safe zone far away. The bomb was set to detonate at an altitude of about 13,000 feet. This altitude produced the maximum explosive power. It also reduced the amount of radioactive fallout. As the bomb fell, the sensors in the nose cone monitored the changing air pressure. When it reached the preset altitude, the pressure sensor activated the bomb's detonator. If you look inside the bomb from this angle, you can see something interesting. There are 2 spheres, one in front and one in back. These 2 spheres are the detonating devices, which are atomic bombs. Around each sphere are high-energy explosives and dozens of detonators. At the very center is a beryllium inner shell and a core only about 6 inches across. The detonators on the outside connect through wires to high-voltage capacitors. These capacitors are charged by the batteries at the bottom. When the explosion triggers, the batteries send a massive current to every detonator through the capacitors. All the detonators fire within just 1/10 of a microsecond. The detonators then set off the high-energy explosives instantly. The explosion creates an inward shockwave that compresses the center of the atomic bomb. The compression keeps squeezing the central core until it reaches a supercritical state. At this point, a huge number of neutrons are released. These neutrons keep striking the nuclei of the core. The collisions cause the nuclei to split into 2 smaller nuclei. This releases a tremendous amount of energy. It also generates 2 to 3 new neutrons. These neutrons keep striking other nuclei. Then they release more energy and create new neutrons. This reaction continues over and over, forming a chain reaction. This reaction releases an enormous amount of energy and heat. The temperature can reach 180 million degrees Fahrenheit. That's several times hotter than the core of the sun. The nuclear fission from the atomic bomb releases huge amounts of high-energy gamma rays. It also releases X-rays. These shoot toward the middle section of the bomb, also known as the fusion stage. The outer layer of the fusion stage is a lead casing. Inside it is the nuclear fuel, lithium deuteride. Right in the center is a rod. The enormous pressure from the atomic explosion presses against the plutonium rod. This produces a large number of neutrons. After the lithium around the rod absorbs these neutrons, it produces tritium. The nuclei of deuterium and tritium, under the 180 million degree heat of the atomic blast, undergo violent nuclear fusion. This releases an enormous amount of energy. Fusion and fission feed off each other, and in less than a microsecond, the bomb is fully detonated. The first thing you see when it goes off is an incredibly intense flash of light. It lasts for more than a minute. Then a fireball begins to expand rapidly outward. It reaches about 5 miles in diameter. That's enough to cover all of downtown Tokyo. If you look closely, you'll notice the fireball isn't perfectly round. That's because in the early stage, the shockwave bounced off the ground. It struck the expanding fireball. This created the flattened shape of the sphere. This kept the fireball from touching the ground. That helped reduce the radioactive contamination on the ground to some degree. Then the fireball kept growing. It gradually formed a mushroom cloud that pierced straight into the clouds. This mushroom cloud eventually reached a terrifying height of about 42 miles. That's more than 7 times the height of Mount Everest. It stretched all the way above the stratosphere. The mushroom cloud was about 59 miles wide. The base of the cloud was about 25 miles wide. The yield of this explosion was 50 million tons of TNT. That was like setting off a magnitude 5.0 earthquake. The Tu-95 bomber that dropped the bomb was about 60 miles away. Even from there, it felt the force of the blast. The plane even shook violently for a moment, but the pilot managed to keep control. Even Norway and Finland, more than 560 miles away, felt tremors like an earthquake. This shows just how earth-shattering the power of a hydrogen bomb really is.